and you can write manuals about your source code while you're actually writing the source code. And then later on, you run one of these programs, and it automatically pulls all the important information out and will let a user see it. So, all right. So, this is the famous question. Indent style and braces. So I think I already told you that my preference for braces is to have them on the next line. However, I will admit that there are other ways of looking at the same problem. Java and C and C++ and all C family languages, and that includes JavaScript, all of them are what we call white space agnostic. That means that we can have empty lines, we can have spaces, we can have tabs anywhere we want, and they will not impact what the program compiles down to. All of those are ignored by the compiler when it's turning it into machine code. And that means that there's a lot of different styles. So you will see a lot of different things in the industry too. I've worked a couple of different jobs and I have my own preferred style, but I will tell you that the best style to use when you're writing code is, what do you think?
New line.
I hear new line and indent. Yes?
The style your company uses.
The style your company uses. That is the correct answer, or the style that the previous code was written in. If you're working for a company and they have a code style format, and they almost certainly do, that is what you should do. Because if you get into a job and you don't follow it, you're going to drive somebody crazy. And you probably don't want to do that when you're the new guy on the block. So, style issues. Any of you guys watch Silicon Valley? Some of you? Okay. Don't break up with somebody because you like tabs and they like spaces. Right? It's, what's that? Oh, yeah. Well, we can talk about that later. Yeah, so stylistic issues, everybody's pretty passionate about them. And the reason I mention this is because we've already had discussions on Slack about how the book gives you one style example, and like not all of us agree with that, and that's okay. The most important thing is that we work well with others, and believe it or not, I have seen people like practically kill each other over this. So it's not healthy for a company or for you as a person. Do try to make your code readable. This is the most important thing. If you're working for a company that already has a code style, readable means the same as the stuff that's already there. Don't try to be unique and special. You are, but in a company, you have to do what they need you to do. So that brings us to variables. The idea behind variables is that we can name a specific location in memory so that we can modify the data there by name rather than by address. So we've already seen several examples of variables. Yes, there we go. So we've already seen several examples of variables in some of the docs, but we may not have called it by that name. A variable is going to have some name. It's going to allow us to store a value, and it's important to note that it can only store one value at a time. This may seem obvious, but it's really important to keep in mind that if you assign a variable some value, and then you give it some new value, if I say x is 4, and then later I say x is 8, that 4 is gone forever. Right? It's gone. I can't get it back. It's really important to remember this because variables are mutable. It means that we can erase what's there and replace it with something else, and once you do that, you can't get back what you had before. Its value can change, and once it does, that's all there is to it. Most variables, and especially in a language like Java, have a data type. And a data type just tells us what kind of information it stores. Now, for optimization reasons, we have a lot of different variants of these because we want to use the most efficient data type for whatever we're doing. So we have lots of different types of integers because most programming we do involves lots of integers. Like they're probably the most common data type. So we have multiple types of integers. We have bytes, we have shorts, we have ints and longs, and these are all different types of integer values that can hold some range of positive and negative whole numbers. Now, beyond that, we're going to get into more detail about this later, but we also have floats and doubles. And floats and doubles are types of floating point numbers, and they allow us to use decimal numbers, basically. They are decimal types, which you might ask, well, why don't we always use decimal types? And the answer is because they are not as efficient in many cases as integers are. Usually using whole numbers makes things easy and precise. When you get into floating point, when you get into decimals and infinite decimals, there's a lot of error that can occur that you will not get with integer numbers. We also have some special data types like the character, which is used for individual characters like symbols in a string. So letters and numbers and punctuation symbols and stuff like that. And then we have Boolean values, which allow us to hold true and false. Like I said, this is an overview. We're going to get into this in more detail, but those are the basic data types we have that we're going to be working with. But let's actually look at an example. Anytime we have a variable, we're going to have a name and a declaration of that. So in this particular example, oh, and I've already made a mistake. I left out the string argument there, but basically this is correct. So here we have the monkey business program, and inside of that we are calculating numbers of bananas and monkeys. Here we're printing out some information. We're assigning some values. First we assign the value of the num bananas program to 10. Then we declare a variable called num of monkeys, and then we set that value. So this is just demonstrating a lot of different ways we can create variables and ways that we can assign them values. So in the first case up here, int num bananas, we're saying this is an integer data type, and we're going to create a variable called num bananas, and then we're going to assign it a value of 10. So we can actually create a variable, we can declare it, and we can assign it a value at the same time if we want to. But we don't have to. We can also declare a variable, like in the next case, int num of monkeys, and then we can assign it a value afterwards. So it really depends on what you want your program to do and when you want to do it. You have some flexibility. And then we can start to do operations with those numbers. We're running out of time, so I'm going to stop it there. If you have any questions, let me know. And, oh no, wait, I'm an hour early. I have an hour.
Oh.
I'm off by an hour. Okay. sorry. I was like, wow, that went by quick. Okay, now we still have some time. We still have an hour. Although we will take a break. After I get finished with this slide, we'll take a break. So, variable declarations basically save a name and they create a memory location to store a value. It includes a couple of different parts of the puzzle. We have to have the type of data that we want. In our case, we're doing integers. We also have to have an identifier. An identifier is a name that we give to that memory location. There are valid identifiers and invalid identifiers, and we're going to look at some examples pretty shortly here. We can also, if we want to, we can assign a value to that variable. So we don't have to set its value at first, but we can. What do you think happens if we don't assign a value?
Gives you an error.
Ah, yes, that's a good answer. So it's Juan, right? Juan said we get an error. And that's right. In Java, we get an error. Do you think that's true in all programming languages? No. Some languages, it'll just give you garbage. It'll just, if you create a variable but you don't assign it a value, it'll store garbage there. And then when you access it, you'll be accessing garbage. We have an expression in computer science, garbage in, garbage out. You may have heard it in other contexts. But it's very common. We forget to initialize a value. We forgot to put something in a storage location, and we get garbage as a result of it. So please be careful about that. Obviously, Java is going to catch that. We just mentioned that. But many languages will not. Many languages will let you do this and get yourself in all kinds of trouble. All declarations, whether they include assignment or not, always end in a semicolon, just like every other statement in Java. All right, does anyone have any questions before we take a break? Yes, sir. Ah, that's a good question. Here, I'm going to repeat it. Somebody said, don't we need a backslash for apostrophes? And the answer is, you actually answered the question correctly too. The answer is not in Java. So if you were going to print a double quote inside of a string, you would need a backslash in front of the double quote if you wanted it inside what you were printing. But that's only the double quote is a special character in Java. The other quote symbols are not. Is that good? Okay. Anyone else? Yes, sir.
How should we practically decide between choosing a short, long sequence and writing it over?
That's a good question. So the question was, how do we pick what type of integer type if we're going to do an integer? And the answer is use the smallest type that is practical for all reasonable use cases or in all possible use cases in some examples. So for example, some types and not all types are equally optimized, right? Bigger types tend to use more information. They tend to be slower. But that all depends on the CPU. Most CPUs today are 64-bit processors. Because of that, the vast majority of data types have the same processing time in modern systems. But I want to prepare you for future languages too. In Java, basically all the integer types are practically the same. So it's really a matter of style and what kind of limits you want to manage. But in a language like C and C++, which you will be getting to next, it matters a great deal more because you can have types that are twice the width of the CPU. So for example, you might have a 128-bit number, like a really, really big number. If you have a really, really big number, then you're going to have to use a bigger data type, but that's definitely going to be slower than the smaller ones. So the short answer is use the smallest type you can get away with without causing a lot of trouble, but it all depends on the type of system you're going to run on. Does that answer your first question?
I had a follow-up.
Let's hear the follow-up.
So the reason that larger processors can work faster with larger types is because the registers are bigger, right?
It's exactly right, yes. So you don't have to know what I'm about to say for class. But the question was, the reason that bigger processors can work on bigger data types is because they have wider registers, and the answer is yes, that is correct. So, good? Okay, yes?
What's that in lines 9 and 11 and 10? No, 10 and 11 is slash n for those.
Oh, wow, that's a really good question. So somebody said, hey, you see these slash n's up here? There's a backslash n. What does that mean? And the answer is, this is a good segue. We're going to get into this in more detail soon, maybe after we take a break. Whenever we want to print a special symbol inside of a string, we have to use a backslash. It's called an escape character. So someone earlier asked about quotes. And for the double quote character, if you want to print or put a double quote inside of a string, you have to prefix it with a backslash. Backslash n means new line. It means start a new line before you print anything after it. So backslash n means new line. Backslash t means tab. Backslash r means carriage return, which is not exactly the same thing as new line, but it's similar. And different systems handle it differently. I forget who asked that question, but it was a really good one. Yeah, thank you. Does that answer your question?
Yeah, true.
Okay. Anyone else have any questions? Okay, let's take a break. Please be back in 15 minutes at 4:15.
Look at the top one. Look who added it. Look at the brands. Remember? And this?
Wait, did you hear how you put quotes within quotes?
Honestly,
Quotes within quotes.
He's-
Like a quote within a string.
I normally use.
Because if I do this string, it's gonna, yeah, so I have to do, but I don't want it to type out the,